Good morning, everyone, and welcome to Lesson 5.5, where we will be discussing writing linear equations given 2 points. By the end of today's video, you should be able to write a linear equation given 2 points, as well as graph it. Before jumping into today's lesson, it is important for me to remind you of a postulate in math, which is just a given fact, that you only need 2 points to graph any straight line. You will recall in our previous lessons that I personally like to plot at least 3 points or more, whatever can fit in a Cartesian plane, because it helps me to line up my ruler more accurately. However, to graph any straight line, the minimum number of points that you need is 2. Just bear in mind that the more points that you plot when graphing, the more accurately you can line up your ruler. So you just heard me mention the term Cartesian plane. As a reminder, a Cartesian plane is a graph that has the x and the y axis. So I wanted to make sure that all of us were on the same page with that vocabulary term. You've heard me use it many times before in class, but this was just a quick reminder. So how can I write the equation of a line given 2 points in a Cartesian plane? When given a graph, this is the easiest way to write the equation of the line. You'll have to follow the next 4 steps. The first is to plot the points on your graph. The second step is to connect the points with a straight line. Please, please, please make sure that you are using a ruler or a straight edge. The third thing you'll need to do is determine the b, aka your y-intercept, and the m, aka your slope. Last but definitely not least, you'll want to write the equation of the line and label it. And this is referring to substituting it or writing the equation of the line in slope-intercept form, otherwise known as y equals mx plus b. Now that we've gone through the steps, let's give this example a try. Given the point 0, 2 and the point 1, comma, -3, what is the equation of the line? So we're going to go through and follow our steps. Step 1 says to plot the points. So we'll place a point at 0, 2, which is on our y-axis. And then we'll also plot the point at 1, -3. Step 2 tells us to connect the points with a straight line and use a ruler. Do not forget to put arrows on both ends of your line. Now that we've accomplished that, we'll move on to step 3, which tells us to determine the b, which is your y-intercept, and the m, which is your slope. Our y-intercept is where the line crosses the y-axis, and it does so at +2. As for the slope, I want to calculate my rise over my run. If I'm counting my slope, I count up 5 spaces, and I count 1 in the negative direction. So my rise is 5, and my run is -1 because I ran 1 in the negative direction. Now that we've determined our b as well as our m, we can go ahead and write the equation of the line. Y equals, my slope will be a -5, because 5 divided by -1 is -5. So y equals -5x, and my y-intercept is a +2, so +2. So the equation of this line is y equals -5x plus 2. Notice that I've written the equation near the line because this is considered as labeling the line with my equation. As a pleasant reminder, please ensure that your notes look exactly like my notes, and then we can move on to the next section. So what should you do if you've been given 2 points only and no graph? How can you possibly determine what the equation of the line is? Well, you can do so using one of 2 different methods, which we'll go over today. So please go ahead and split your space in half like how I have and label the first side as method number 1. To give you some context of what we're talking about, take a look at the first example down below. Given 5, -2 and -4, -3, what is the equation of this line? If when you looked at this question and the first thing that came to mind was, hey, I need to determine what the slope of this line is, you are correct. So step 1, you want to label your points as x and y and calculate your slope. As a reminder, the formula to calculate your slope is y1 minus y2 divided by x1 minus x2. Or you can think about it as y2 minus y1 divided by x2 minus x1. It doesn't matter which version of the slope formula you want to use. What is important is that the order of the ordered pairs that you're placing in the formula remain consistent. So the first point goes over the first point for x and y, and the second point goes over the second point for x and y. For step 2, you're going to choose one point. It doesn't matter which point you choose because you'll end up with the same exact equation. But you'll choose one point and substitute it into y equals mx plus b along with the slope that you solved for in step 1. The reason you're doing this is because you need to solve for your b, aka what is your y-intercept. Method 1 only has 3 steps. That's why you see me whiting out the misnumbering here. And for step 3, you are going to write the equation by substituting m and b into your y equals mx plus b formula. The y and the x will remain the same, and then you'll substitute the numerical values that you have for m and b in the formula. All right, so now that we got our steps down, let's tackle this example problem. So again, given the point 5, -2 and the point -4, -3, what is the equation of the line? So we're going to start with step 1. Step 1 tells me to label the points as x and y, so x1, y1, x2, y2, and to calculate the slope. It's super important to keep your workspace neat and organized, so you'll see me here labeling the step 1 area in order to demonstrate that I'm calculating for my slope. Now that I've labeled my points, I'm going to take them and plug them into our slope formula. So for y1, I'm going to substitute -2 minus -3 as y2 divided by x1, which is 5, minus x2, which is -4. I'll then go through and simplify. -2 minus -3 gives me a difference of 1, and 5 minus -4 is 9. So my slope for this line is 1/9, and I'm labeling that as my m. Step 2 then tells me to choose one point and substitute it into y equals mx plus b with the slope in order for me to solve for what my b is or what my y-intercept is. Remember, it does not matter which of the 2 points you choose because you'll still come out with the same equation of the line. Just for demonstration purposes, I'm going to choose the second point, the -4 and -3. I'm going to substitute in -3 for y. I'm going to substitute m with 1/9. I'm going to substitute x with -4 and then replace the plus b because I'm solving for what the value of b is. The left side of my equation stays the same, so I'll bring down that -3. I will now need to multiply 1/9 and -4, which gives me -4/9 plus b. To isolate b, I will need to add 4/9 to both sides of my equation. You'll see me rewrite -3 plus 4/9 equals b. I'll then convert my whole number into a fraction with an equivalent denominator. So instead of -3, I will write -27 over 9, because -27 divided by 9 is equivalent to -3. And -27 ninths plus 4 ninths equals -23 ninths. So B is a value of -23 over 9. To follow step 3, we must write the final equation by substituting the value of m and b into our slope-intercept form. So you'll see me rewrite our equation. Y equals m is a value of 1/9 x, and then plus b, or in this case, minus 23/9, because the 23/9 is negative. And this is the final equation to our line. Notice that it is okay to have fractions as my equation. In this case, it doesn't really bother us too much because we're not graphing, but this is acceptable to have two fractions in the equation of your line. Now that we've covered method number 1, let's take a look at method number 2, which you are already familiar with. So for method 2, we're going to convert from our point-slope form into our slope-intercept form. In the event that you forgot about point-slope form, you can look back at lesson 5-2 to refresh your memory. So many of these steps are pretty much the same. Step 1, if I'm given 2 points, the first thing that I need to identify is the slope. So you'll label the points x and y and determine the slope. Step 2, you will choose one point, any one, doesn't matter, but you'll choose one point and substitute it into the point-slope form along with the slope itself. And again, you can refer to lesson 5-2 for your point-slope formula, which is y minus y1 is equal to m multiplied by the difference of x minus x1. And then last but not least, for step 3, what you'll do is solve for y. With this method, you are converting from one form of a linear equation into another form of a linear equation. So let's take a look at this example down below. Given the points 4, -2, as well as -4 and -4, what is the equation of the line? So again, I'm labeling my space in order to keep my work area neat so that way I can follow my math. Following step 1, I'm labeling my points x1, y1, x2, y2, and now I'm going to calculate my slope. For y1, I'm substituting -2 minus -4 for y2, divided by the difference of x1, so that's 4, minus x2, which is -4. To simplify, -2 minus -4 gives me a value of 2. 4 minus -4 gives me a value of 8. Remember that your slope must be in the most simplified form possible, so I will use the slope of 1/4 instead of 2/8. For step 2, I need to choose one point and substitute it into our point-slope form. Again, I'm labeling my work area in order to keep it neat. And our point-slope form is y minus y1 is equal to m multiplied by the difference of x minus x1. For demonstration purposes, I'm going to choose the first point, which is labeled x1 and y1. I do not have to use this point. I could very well have used the x2 or y2 point if I wanted to. Remember, you can choose either of the 2 points when you are solving at this step. When I'm substituting, the first y stays the same. y1 gets substituted with -2. Our slope that we're working with is 1/4, and that's multiplied by x minus the value of x1, which is 4. Now that I have my equation in point-slope form, I'll then work to convert it into slope-intercept form. I'm just going to bounce my equation further up so that way I have enough space to work. My equation becomes y plus 2, remember that double negatives become a positive, equals 1/4 multiplied by the difference of x minus 4. To begin isolating y, I'll need to first distribute that 1/4 into the parentheses. So my equation becomes y plus 2 is equal to a fourth x minus 4/4. Remember that you multiply fractions going straight across. I'll then go ahead and rewrite the simplified version of this. So y plus 2 is equal to 1/4 x minus 1. I can rewrite this as minus 1 because 4 divided by 4 equals 1. Now to isolate y, I want to subtract 2 on both sides of my equation. Our final answer will be y equals 1/4 x minus 3. And this is our final answer. Keep in mind that our equation y equals 1/4 x minus 3 will produce the same exact line as our original point-slope formula of y minus -2 is equal to a fourth the difference of x minus 4. Essentially, these two equations are exactly the same thing because they produce the same line. Please ensure that your notes look exactly like my notes. Once you have done so, go ahead and turn over to the student page. For this lesson, you will have a total of 5 questions to answer. 2 graphing questions and 3 calculating questions. Please answer the calculating questions the following way. The first question, please use method 1 to solve. For the second question, please use method 2 to solve. For the third question, you can choose the method of your preference. Alright guys, so we've reached the end of today's lesson. As you know, due to COVID-19, which is commonly known as
coronavirus, woo!
We have transitioned to the distance learning model. So once you've completed watching this video, please complete your student pages and upload them to the posted Google Classroom assignment by 11:59 p.m. tonight. Today is March 24th, 2020. I will be checking and uploading your grades tomorrow. With all of that said, y'all, please be safe. Please stay indoors. Wash your hands. Practice social distancing. And just remember to love each other and to be kind. Happy notebooking, y'all. Talk to you later.